In this video, we're going to learn how to solve double linear inequalities, which have an x term on the left side, in the center, and on the right side of the inequality. So throughout this video, we would look at different variations of this type and also different types of solution it results. So let's look at our first example, which is 4x minus 2 less than or equal to 5x minus 6 less than or equals to 4x plus 4. So what we are trying to do here is to find all the values of x that would make 4x minus 2 less than or equal to 5x minus 6, and also 5x minus 6 less than or equal to 4x plus 4. Or in other words, we're trying to find all the values of x that makes 5x minus 6 fall between 4x minus 2 and 4x plus 4. So this is one of the easiest ones to solve. As you can see here, on the left side and on the right side, we have the same x term, which is 4x. So it is very easy to eliminate the term from the left and right such that we only have x term in the middle. From there on, we can solve for x very easily. So to do that, let's subtract 4x from both sides of the inequality. To balance the inequality, we also have to take away 4x from the center. So we get negative 2 less than or equal to x minus 6, which is less than or equal to positive 4. So now we have x only in the middle of the inequality. Now to isolate this x, we have to eliminate negative 6. In order to eliminate negative 6, we add positive 6 on every part of this inequality. And we get 4 less than or equal to x less than or equal to 10. So we have already isolated x in this inequality. So what does that mean? It means if we use any value between 4 and 10, it is going to satisfy our inequality. In other words, the inequality is true for all the values of x greater than or equal to 4, and also for all the values of x less than or equal to 10. You could also graph this on a number line. Since we have only one variable in our inequality, we just need a number line to graph this inequality. If we had two variables, then we might have to use a coordinate plane to graph the inequality. So first, let's graph x greater than or equal to 4. Since 4 is included, we use a closed circle. Then shade all the values greater than 4, including 4. Next, let's graph x less than or equal to 10. Since 10 is included, we use a closed circle again. Then shade all the values less than 10, including 10. So here you can see the values between 4 and 10 overlap. That means all the values between 4 and 10, including 4 and 10, would make our inequality true. We could also use interval notation to represent the solution. In this case, our lower limit is 4. Since x is greater than or equal to 4, that means 4 is included, we use a square brackets beside that. And our upper limit is 10, which is also included because x is less than or equal to 10. So we use another square bracket beside 10. If the values were not included, for example, if it was x greater than 4, not equal to 4, we use a parenthesis instead of brackets. Now, let's look at our second example. In this one, we don't have the same case as in example 1. Here, the x terms on the left side and on the right side are different. There is positive x on left and negative x on the right side. So if we try to eliminate x on the right side, by subtracting x, the left side is going to have negative 2x. So there is no way to add or subtract x to eliminate the term from both the sides. So in this case, we're going to take a different approach. So for that, let's split this double inequality into two separate inequalities. So that is negative 10 minus x less than 2x plus 2 and 2x plus 2 less than or equal to 23 plus x. So now let's solve the first part. So first, let's bring all the x terms to the left side of the inequality. So for that, let's eliminate the x term on the right side by adding negative 2x on both the sides. So we get negative 10 minus 3x less than 2. Now let's isolate the x term on the left by adding plus 10 on both the sides. So now we have negative 3x less than 12. Next step, we need to isolate x. So we divide both the sides by negative 3. When you deal with inequality, whenever you multiply or divide both the sides of the inequality by a negative value, the sign flips. So less than becomes greater than sign. So you get x greater than negative 4. So this is one part of our solution. So now let's consider the second part. First, let's bring all x terms to the left. So for that, let's eliminate the x term on the right by adding negative x on both the sides. So we get x plus 2 less than or equal to 23. Now isolate x on the left side by adding negative 2 on both the sides. We have x less than or equal to 21. So this is the second part of our solution. So the final solution to this inequality is going to be all the values of x, which is greater than 4 and less than or equal to 21 simultaneously. Let's graph this on a number line. So first, let's graph x greater than negative 4. Since negative 4 is not included, we use an open circle to mark the point. Then shade all the area which shows greater than negative 4, which is basically all numbers greater than negative 4 till positive infinity. Next, let's graph x less than or equal to 21. So we use a closed circle to mark 21 since 21 is included. And then you shade all the area which is less than 21, that goes up to negative infinity. Now to find the values of x that would satisfy both parts of the inequality, we have to find the area that overlaps. So in this case, it is the area between negative 4 and 21, where 21 is included. So one way to write the solution is negative 4 less than x less than or equal to 21. Another way is to use the interval notation. So here we use parentheses beside negative 4 because negative 4 is not included. And we use a bracket beside 21 because 21 is included. Let's move to our next example, example 3. So this one is similar to our previous example in terms of the x terms on the left side and on the right side. Here again, we have two different x terms on the left side and right side of the inequality, so 2x and 5x. So we cannot just eliminate by subtracting or adding a 2x or a 5x on either side. So to solve this, we split this inequality into two parts again. So first part is 2x plus 13 less than 4x plus 3, and our second part is 4x plus 3 less than 5x minus 4. Now let's bring all x terms on the left side by adding negative 4x. We get negative 2x plus 13 less than 3. Now isolate the x term on the left by adding negative 13 on both sides. We have negative 2x less than negative 10. Isolate x by dividing both sides by negative 2. So when you multiply or divide an inequality by a negative value, the direction of the inequality will be switched. So less than is switched to greater than sign. So we have our second part, the first part of our solution, which is x greater than 5. Now let's move to the second part of the inequality, which is 4x plus 3 less than 5x minus 4. So we follow the same rules to solve by bringing all x terms to the left, isolating the x term, and then isolating x and solving for x. We get x greater than 7. Now let's graph this on a number line. Let's consider the first part of the solution, which is x greater than 5. Since 5 is not included, we use an open circle to mark 5 and then shade all the areas that is greater than 5. So that goes up to positive infinity. Next, let's graph x greater than 7. Again, start with an open circle to mark 7, since 7 is not included. Then shade all the values greater than 7, and that goes to positive infinity again. Now, the values of x that is true for both parts are the area that overlaps. So in this case, all values of x greater than 7 till positive infinity. So to write this in interval notation, we use a parenthesis beside 7 because 7 is our lower limit and 7 is not included. And our upper limit is positive infinity. So whenever you're dealing with a positive infinity or a negative infinity, you always use a parenthesis next to it. So 7 in positive infinity is our solution in the interval notation. So this example is different from our previous example in terms of the solution. So in this case, we only have the second part of the inequality to represent the solution, which is x greater than 7. That means this inequality is true for all values, which is greater than 7, that goes to positive infinity. Let's look at example 4. Here again, we have an inequality which has two different x terms on either side of the inequality, which is 8x and 10x. So again, we have to follow our second approach, which is splitting the inequality into two parts and then solving for x separately in two parts. So let's consider our first part, which is 8x minus 5 less than 6x minus 15. And our second part is 6x minus 15 less than 10x minus 24. So first let's solve the first part of the inequality. And we follow the same rules by eliminating x terms from the right and then isolating the x terms on the left and finally isolating x. We get x less than negative 5. So that is the first part of our solution. So let's solve the second part of the inequality. Again, you eliminate x terms from the right side, so you add negative 10x on both the sides, so you get negative 4x minus 15 less than negative 24. Then isolate the x term on the left side, so you eliminate negative 15 by adding a positive 15. You get negative 4x less than negative 8. Again, isolate x by dividing it by negative 4, and the sign flips because you're dividing it by a negative value. You get x greater than 2. So that is the second part of this solution. Now let's graph these solutions on a number line. So we have x greater than 2. So we start with marking 2 with an open circle because 2 is not included. And then shade the area that is greater than 2. And that goes to positive infinity. In our second solution, which is x less than -5, again, -5 is not included. So you start with an open circle to mark -5 and shade the area which is less than -5. That goes to negative infinity. And what do you notice here? So the solution to this inequality, 8x minus 5 less than 6x minus 15 less than 10x minus 24, is all the values of x that satisfies both part of the inequality, that is x less than -5 and also x greater than 2. But in this case, it does not overlap. So we have no solution to this inequality. So how this inequality is different from all the other inequality is that there is no solution to this particular inequality.